All right, today we're going to talk about batteries, and I'm going to try to explain to you how a battery actually works here with a little example. So, basically, a battery has two compartments. It has a uh, positive and a negative compartment, and those two compartments are able to hold what's called electrical charge. So, when we charge a battery, basically what we do is we put electrical charge into one of those two compartments. And so, as you can see here, I'm putting some electrical charge into this compartment, and one of the sides or compartments of the battery might now be considered to be charged. But nothing is happening because there is no way from this charge to move out of that compartment. So what we do is we would connect battery to a wire, and I'll just use this straw here as an example of a wire, uh, in order to enable the charge from one compartment in the battery to move to the other compartment in the battery. But if there isn't much charge uh, in that one compartment of the battery, then you're not going to see a lot of charge moving uh, from one compartment to the other. The movement of that charge is what we call current, electrical current. So if there isn't enough charge in the battery, you won't see hardly any electrical current when you connect a wire or a straw, in this case, as an example. So if we continue charging the battery by putting more charge in it, then we build up the electrical pressure, which we call voltage, and at some point we will see that there will be current flowing from one compartment in the battery, which may be, for example, the positive terminal, to the other compartment, which may be, for example, the negative terminal, through something called a wire or a conductor, because it is conducting the electrical charge from one component to the other. The amount of charge that I put into this particular battery will determine the voltage that that battery has, or the electrical pressure. And as you can see, as the electrical pressure or voltage goes down, the amount of pressure going through the straw also goes down, and the amount of charge and the amount of current will also go down. So, how do we remedy this particular situation? We basically have to recharge the battery. And when we recharge the battery, we're just moving the charge back to this other compartment here so that there will be enough pressure to basically uh, enable the current to flow that we want. Now, the capacity of the battery is measured in something called amp hours. So amps are a way of measuring the amount of charge that is moving through the wire, or in this case, the straw. Amp hours is how much of that charge is moving or can move through that straw or that wire within 1 hour. So if a battery has 3 amp hours, it can basically move 3 amps of charge in 1 hour before it's discharged. If a battery has 5 amp hours, it can move 5 amps of charge in an hour before it's completely discharged, etc., etc. The voltage of the battery is the amount of water or pressure that the battery has. So, for example, I will get more pressure coming out of this, more water pressure coming out of this supposed battery that I have here by simply making it higher, because now we have more gravitational pressure on the water to push it out versus bringing it closer to where it's going. Another way in which I can increase the pressure is just by increasing the amount of charge that I put in this one compartment, or the amount of water. And if you look around, you'll see that's actually how water towers work. They basically take some water and they pump it up to a high elevation, and that causes the pressure of that water in the surrounding area to be much higher than it would be if for example, the water was at ground level.